morning, and welcome to Cosmic Conversations here on the Morrison Planetarium Facebook page. My name is Ryan Wyatt. I'm the Senior Director of Morrison Planetarium and Science Visualization at the California Academy of Sciences, and I'm really pleased today to be joined by James Hedberg, a physics lecturer and Director of the Planetarium at the City College of New York. Thanks for joining us.
Thank you for having me. It's been great.
We're going to have kind of an interesting discussion today, I think, because we've never in the many months now that we've been doing our conversation series, we've always focused on modern astronomy and planetary science. And we're going to kind of turn back the clock a little bit today and look at some historical data in astronomy. So thanks, James, for giving us this kind of look backward into to some of the catalogs of stars that were the foundation of astronomy. Well, to begin with, I think we're going to start our story in Alexandria with Ptolemy. So I'll go ahead and fly there, and maybe James, if you want to give us a little background on Ptolemy.
Well, I mean, the project started because I'd always had an interest in ancient astronomy, and even read some Ptolemy back in undergraduate.
As you do.
Yeah, as you're likely to do. No, there's one little school in New Mexico, and also it's just another campus in Maryland where everyone has to read some Ptolemy for math class in freshman year. But we didn't focus a lot on these star catalogs. We did mostly the geometry of the goals and all of that as a way to learn basic geometry and the proof structure. And then more recently, now that I'm in the City College Planetarium, I'm always looking for fun stuff to put on the dome. And I had seen some recent, they released machine-readable versions of the catalogs within the last 10 years.
So very cool, yeah.
So we can figure out how to display them in a way I hadn't seen. I'm sure I think people have done it, like put them into visual context, but usually if you see a paper on these data sets, they're always it's like error plots and
right. Well, I mean, actually, in terms of, as we fly into this, I think one of the things that's so striking about putting this in sort of geographical context is, we flew into Alexandria, Egypt, and it's right here on the kind of sort of westernmost edge of the Nile Delta. And I think what I'm always amazed in the satellite image, like how apparent that feature is, and of course so critical to the development of culture in the region and the importance of things like navigation and mathematics for people who are sailing around the Mediterranean and trading. So how much was part of Ptolemy's story in terms of developing the catalog and the techniques he used?
You mean just where he lived?
Yeah, I mean, the fact that it was happening here and not someplace else in the world.
That I don't know a lot about that, to tell you the truth. I mean, he was Greek, but lived near Alexandria, and I guess one common misconception is he's not the Emperor Ptolemy,
right,
of Egypt. That always comes up, but
different family lineage.
Yes. I guess I wondered, so when you were, well, you don't have to zoom out, but it was so green and lush looking from space. I wonder has it always looked like that, or that more due to recent irrigation? And I don't know.
Well, certainly the flooding of the Nile was an important part of the Egyptian calendar system, and the reason that many thousands of years before Ptolemy, the calendar was developed. So I guess I was always curious about the relationship between Ptolemy developing these tools and how that kind of interwove with the economics of being a port city in this trading empire. But
I'm sure that there was some connection. They probably wouldn't have been able to do it if he was in a less scholarly part of the world at that point.
Well, I guess we could pull out and actually then look at the catalog here and again, sort of put this in context. When we started the program, and as I pull out, we'll have our sort of modern star database displayed But then I can add the locations of the star positions from Ptolemy. So we've added those locations in kind of this blue shade.
Mm-hmm.
And we're sort of looking over here at kind of Sagittarius and Scorpius.
Yep.
So what are some of the things that struck you about?
Well, I mean, in importing them, I guess, from the technical point of view, it took me a good while to figure out all of the coordinate conversions and everything to get those data sets just into OpenSpace. So OpenSpace requires a rather a finely tuned data structure to plot these stars, because it's doing a lot more than just putting dots in the right place. It's shading their magnitudes and doing.
Well, and Ptolemy didn't have the sort of right ascension and declination system that we have today.
Yeah, if there's the catalog right there, and you can see he gives. I think one of the big achievements though with the Ptolemy was putting all the stars in the same data structure. So that was the problem before this. The previous catalogs that he, based this off in whatever way, they would have, some were missing one component, some had equatorial coordinates. He put them all into ecliptic coordinates with longitude, latitude, and a magnitude, and a written description of the star. And so just from a perspective of like a catalog of anything, he made a significant achievement there by having a uniform structure of data.
So for all parts of the sky using the same kind of system.
Yeah. Yes. Yeah.
Well, we also had, I think, a diagram of some of the systematic errors as well. And this was maybe a more baffling kind of piece to look at.
Yeah, the resolution was of the paper that this was from is a little bit just dated, I guess, so it doesn't come out as well as maybe a newer version could. But this shows what's essentially this huge, I don't want to, not necessarily controversy, but conflict with the data with Ptolemy that historians of astronomy have been struggling with since Tycho, actually, for hundreds of years. He was the first to notice it. That
interesting.
Go back and figure out where the stars should have been in the year Ptolemy claimed they were. The measurements were done, which would have been 138 AD.
Mm-hmm.
So now we can go back and plug our precession calculators in and figure out where everything should be at that point. Everything's off by a degree or so on average, and this has led to many different hypotheses about where how the catalog was constructed. I don't think there's a consensus yet, but anyway, that was the first thing I, had to figure out, is how do you portray this data in a fair way? Like, I didn't want to plot it all wrong. I wanted to plot it as sort of correctly as you could. So the average, equinox that kind of gives the best fit for everything is around 58 AD. That was figured out in 100 years ago in the Peters.
So almost a century before the sort of estimated date when he would have been doing the work.
Exactly. Yeah. But so it leads one to think maybe some of the measurements were not done by Ptolemy, but were from the Hipparchus.
But even at that, like you said, he compiled all of these into a systematic.
Yeah, exactly. It was a major achievement, and part of the discussion again is about scientific ethics and whether it's fair to say you made a measurement when you didn't do it, but they weren't working with the same structures we were as far as copyright goes. And
if only they had peer review, maybe that could have been highlighted earlier. I know that one part of the sky, that we talked about was Orion, so I'm going to try to steer us around and be looking in that part of the sky.
Yeah, you can see they're all off. Every single one of them is a little bit off, but with this average epoch, they're all off in slightly different directions.
Interesting.
And then part of the studies also go through and they clump them into different constellations. So if you if you look at the catalog, originally everything's measured with respect to a zodiac. I forget the name of the word, but the 12 points along the 360 degrees. And so you can find different errors if you zoom into certain constellations.
Right.
And that's what that plot was you just showed. I was highlighting there was the Orion stars had their own error that's different than like the stars in other constellations.
And I finally kind of laboriously got us over here to Orion. Let me kind of see if I can get Orion in more of a yep. This is one of those challenges of using a Mac keyboard with a Windows program. I occasionally get a little
you got to use the force.
Exactly, to bring the universe around where we want it. But sort of bringing Orion around to what we think of in the northern hemisphere is more right side up, with kind of Earth in between Orion and Taurus, and then the Pleiades eventually here is kind of to the top of the screen and off to the right. Yeah, you can really see some kind of interesting inconsistency there.
Yeah. Yeah, so the three stars along the belt are not quite in as straight a line.
Well, I can blink off the Hipparchus stars, or the stars.
Yeah, the modern stars are gone now, so that's the celestial sphere as Ptolemy recorded it.
Very interesting.
Yeah.
I mean, it's kind of an interesting question too. I mean, did he ever have a chance to sort of plot star positions like this, or was it kind of,
I think the idea is no. Like it's unlikely he ever. Well, it's pretty much guaranteed. I think that they ever drew a map in the same way we would today, where you do X and Y and like make a celestial map. The idea of doing that didn't come around for a while. There might have been I think there's talk of a actual physical sphere that might have been passed around by the astronomers that had these stars on it, and that maybe that actually played some role in his conversion of the ancient data to the less ancient data. But as far as visualizing it like this, no, it's unlikely he did that.
Was an interesting argument actually in favor of visualization techniques to kind of as a litmus test for your data, right? Because I think if you were, had looked up at the sky and you plotted your data and you showed Orion looking like this, you'd kind of say, oh, maybe I've got some problems there.
Mm-hmm. Yeah, it's useful. It's a useful tool. You can see. I love how the stars of his shield, they're way more obvious in this table. So it does make me think maybe there was some visual context that he was working with.
That's interesting.
Right. That looks less like a shield when you look at the modern view than when you just turn on his.
Oops. And these are his star brightnesses as well. So
exactly.
It's like he artificially inflated the brightnesses of these objects.
Maybe,
as well.
yeah. So he only had 6 magnitude.
Okay.
And there's even within those 6, there's some they're not equally distributed and
right.
But
well, then I guess we also have another star catalog here that comes from a slightly different part of the globe, although not terribly far from Ptolemy. And that's the Ulugh Beg catalog. And what's his story?
He was a very, I guess, wealthy would be the word, person of means in ancient Persia, and built an amazing astronomical observatory with, again, all non-telescope, non-optical instruments, but enormous sextants and armillary spheres and other ways of measuring positions in the sky mechanically with the eye. And so he built that and assembled a better catalog. So
and this is several centuries after
1400s, I think, something like around there.
So we can bring up his stars as well here.
Yeah, so they're a little bit they're noticeably better than Ptolemy's as far as they're mapping to the modern measurements. But his catalog didn't ever reach the acclaim of Ptolemy's.
Interesting.
Yeah.
And was that just because Ptolemy maybe had more of an installed user base of printed versions that were?
Yeah, it had been around for 400 years already, 500 years, and then as we'll see in the next one, there was an even better set that came along not too long after Ulugh Beg.
Well, would you like to start by visiting Uraniborg, or should we show the Star Catalogue first?
Let's go back to Earth. I think that's fun to start from Earth and see where Tycho was hanging out.
Sorry, let me get us back.
And yeah, there he is. So that's the famous quadrant mural, a mural quadrant that enabled a lot of these fantastic measurements to be made without telescopes. And this was all taking place on this little island up here.
And Tycho is Danish, right?
Yeah, he's Danish. This island, is this the right island?
Oh, yeah, I'm hoping will be.
Okay. Oh, yeah, there it is. Yeah, that little teeny one. I think the island's in Sweden. I'm not sure where the boundaries were back then, but yeah, he was a Danish astronomer. And he built this. You can see as we get a little closer, start to see some tributes to an amazing astronomical observatory that used to be there. It's no longer there, but there's a museum, I believe. And
I will note as we get closer, we discover that on this island they evidently grow, like, I don't know, some mustard or poppies or something, because it's like insanely bright yellow.
I meant to look up what that is. I feel like that's something that we should be able to find out. I don't know what it is.
Right. But yeah, here we have a digital model of the instrument kind of superimposed on.
Yes. So this is larger than it would be in real life, but it gives the idea of the sort of basic instrument we're talking about.
And a lot of these are gone, but actually I think we do have an image that shows a kind of layout of Uraniborg in Tycho's time. And actually, I think we have another one, that one, yeah. And actually, I think what's cool is that I look at the satellite image here, and I'm convinced I'm seeing some of the same garden structure. So
yeah, maybe maybe it's left over. Maybe that same structure is left over, or maybe it got rebuilt. I don't know. I've never gotten a chance to actually visit the museum that's there, but it does look the same square. As you see, like old mound, like squares on the left, or a wall that looks like an old mound.
Right.
Maybe that was part of it.
Oh, that, yeah. Well, yeah. I think Tycho was sort of infamously not a very pleasant person. And so at least one story I've heard is that as soon as he was basically kicked off the island for political reasons, that the populace basically just raided anything that was left on the site for stones or brass or whatever they could get their hands on. So he definitely did not make any friends, because he was like the landlord, as I recall, of this estate as well. So
okay.
But anyway, the instrument.
Yeah, the quadrant. So you'd be down there standing where he is next to the markings on that quarter sphere, and look up through I'm all basing this on the classic image of the mural quadrant. There's a little hole in the wall, and I think you can, it's a little hard to do it in open space because of the geometries involved, but if you peek through that little hole, you'll see stars. And then you would, as they crossed a certain part in the sky, then you would be able to see them in that gap and make a note of when they were there, and create your catalog.
Yeah, because what was the actual size of this quadrant? I mean, I guess the image that we had up earlier gives a good sense of scale.
Yeah,
Well, we got two different scales.
Yeah, that image gives a terrible sense of the dog is
right
as a man.
Tycho had his very petite assistants.
I think they're roughly building size, small.
Wow. At any rate, this larger scale and being able to position and kind of use this as a positioning instrument gave much better results. I guess.
Yeah, and he also used other instruments too. So part of the statistical analysis of all these things, of all the catalogs, looks at the instrumentation that might have been used, and he, cross-checked between different instruments more so than anyone.
Okay.
Did.
So rather than relying on kind of one.
Yeah, like if one of your reticule or graticule, what do you call the little markings on the
right
was off on one instrument, you could fix it by comparing different instruments. Anyway, can you turn on the Tycho?
Yeah,
stuff?
actually, totally. Get a little farther away from home here. And bring up Tycho's catalog. And yeah, this is pretty striking.
Yeah, so this is sort of how I knew my conversions were okay. My AstroPi coordinate conversions is that Tycho's lined up almost perfectly on everyone.
Wow.
It's hard to find a case where it's obviously an error or something. There's a few. I forget where they are, but there are a few.
I guess that's kind of an interesting question. I mean, so going back to that visualization sort of oriented question, is there any sense that we have that Tycho would have actually taken the time to plot this or used?
I think also no. I think it's
interesting.
Yeah, as far as I'm aware, like it was only maybe within the next century after him is when the classic maps of this classic celestial maps started being produced.
Interesting. Right. Yeah. That sounds about right.
I think so. And I guess, yeah, you have to, I mean, it gets into why were they even doing, why did they do this work, right? And I don't think it was to make wall hangings and stuff like that. So why map it out? If you have it, table of data is always more useful for a scientist than a drawing.
Well, then the star positions, I mean, yeah, that is an interesting question. So the star locations were really then used as a way of increasing accuracy of making planetary measurements then, since planets were important for kind of astrological reasons.
In many ways, they were probably done in service of different cosmological models.
Right.
So Ptolemy needed his to show that his model of the solar system fit. And Tycho was doing that. I think, as far as I know, he had the same project going on. There's the Tychonian system where the sun, the Earth is in the center. The sun orbits the Earth, but everything else orbits the sun.
Yeah, Tycho's great compromise.
Yeah, exactly. And so he needed to show that it could predict stuff out there, and in order to do that, you need good background star maps. So he did that.
And then, of course, Johannes Kepler goes on to use Tycho's observations to really shake things up.
Yeah, this data is actually from Kepler's book.
Okay.
He took delightfully scandalous stories about Kepler maybe
absconding with the data.
But anyway, he published them and corrected some stuff, I think, and then used them to fix the problem of circular orbits. Well,
then since we were comparing the Orion locations earlier, I think this is very telling to see how neatly, especially in this part of the sky, these really line up.
Yeah, that looks like the Orion we know.
Yeah, it's
Taurus over there. The question, my favorite is Ptolemy. That's, I think, seeing a data set from 2,000 years ago.
Yeah,
it doesn't happen that well. I guess for me it happens every day because I've been playing with this stuff. But, there's not, I guess, and the other data sets that people have discovered and brought back from those years are not quite as interesting. There's lots of commerce, spreadsheets of trade and salaries and so forth.
Not as compelling.
Not as much about the natural world.
Right. Well, then I think there was another kind of cool punchline here. If we pull back, and let me go ahead and right now I have Ptolemy's catalog along with Tycho's, and so I'm gonna kind of brighten up these points representing the two. So with these kind of blue points representing Ptolemy's data, and then this is a nice little demonstration of the open space interface for anyone who wants to sort of follow along at home. We often try to conceal this actually in our presentations, but it is actually kind of cool to sort of.
That should be brought up. Anyway, if you have a decent computer, you can download all of this stuff yourself and play with it.
Right. Actually, we should probably. Well, I think we have a URL to share with kind of a write-up that you did for this, but also that you have a GitHub where people can download this. So once you've got open space installed, it's not a default part of the open space.
No, this is what you call a idiosyncratic add-on, maybe.
Right. But that's what open source is all about, right?
It is, yeah. So that's why part of the reason I love the software is you can build your own stuff with it. And anyway, so go ahead with what you're going to show here.
Oh yeah, so this is kind of an interesting comparison. I mean, going back to those models of the solar system, and for a long time it was a very difficult. Well, it is a very difficult measurement to figure out distances to stars. So we're kind of again presenting this data. You sort of chose what I think Ptolemy or Tycho would have been very comfortable with, this, which is sort of the sphere of stars. And I think what's great is, as you pointed out when we were talking about this, is that you can also very clearly see sort of the limits of the data, and that these observations were made from different latitudes on Earth.
Mm-hmm. Yeah, so the lower half of the sky was completely off limits just because of where they were.
And so Ptolemy, because as we saw, it's a little farther south, had more access to the southern sky, so he's got a few more data points down in that part of the sky, which is kind of cool. Yeah.
And then it was Edmund Halley who filled in the southern cap a couple hundred years later with the voyages down to the southern hemisphere. So he added 300 or so stars to these catalogs, and then it filled out. And that I just found the machine readable version of that data, so I'm going to try and
very cool.
plot it in here too, so we can get the full.
And did he do northern hemisphere as well then, or he just kind of relied on the other?
Not to my knowledge. I think maybe he did, but what he left and people have celebrated since then is the southern catalog. He did also, I think he was the first to he used the Ptolemaic catalog. This would have been in, 1600s, I guess, right? He used the Ptolemaic catalog to show that there was some proper motion of the stars.
Oh, okay.
So that some of these errors are in fact due to the stars moving since 100 AD.
Right.
So Sirius, the dog star, is one of the. He pulled out 3. Sirius and Aldebaran, and a third. He was able to show that the errors were not. They were different errors, and so he ascribed them to motion of the stars. And as usual in these seminal works, a tiny 3-page little article that said, "Hey, maybe the stars move."
Very cool.
Yeah. So the Ptolemaic system, it's been used recently.
And Actually, I should have been noting all along that if you do have any questions for James, please don't hesitate to put them in the chat, and we're happy to address those in the flow of the program. A little reminder there on the visual reminder as well. I realized we also had some constellation imagery. I don't know if you wanted to touch on that as well.
You can show them. They're all. These are just the. In Ptolemy's time, there were 48 constellations.
Sorry, having said that, I now have to find them on my my cheat sheet here.
Right. And in the catalog, so if you go and look at the catalog, they're all listed. Everything's all the stars are listed with respect to the different constellations. So they go in order, starting from Ursa Major.
Okay.
And it's a little, the sky's a little sparser with only 48 up there.
Right.
Yeah.
So if we, because we're kind of looking in the equatorial region now, but if we pivot to look toward the southern sky.
Yeah, it should be a kind of, after Argo down there, it should be kind of empty.
Sort of suspiciously blank. Yeah.
Yeah. Yeah. So
well, and then going back to Halley and his observations, and it's also why our official southern constellation names are kind of anachronistic compared to the other constellations.
Yeah, they were all much later on, at least for these IAU official constellations. There's, of course, loads of other constellation sets out there in the world.
Well, actually, having mentioned, and I sort of just to throw this a little bit out of left field because we didn't really talk about it before, but since if these catalogs were primarily intended, because we're looking kind of at Virgo here, we got Libra. I mean, if they were intended to be used more for comparison with planetary locations, is there any sense that the catalogs were more accurate along the zodiac?
Definitely. Along the
Interesting.
I don't think it's not due necessarily to the stars being within the zodiac. It's due to being on Earth, and I think the stars closer to the poles were harder to get good measurements of.
Right.
So if you look at that first, the error plots image that we had, the ones with higher latitudes, and
so this one.
Yeah, like if you look on the far left there, the lines get a lot longer around right in the latitude. If you look at the large latitude stars, you can see a larger error there.
Because basically the rectangle on the left represents the entire sky.
That's the whole sky. The subset there was me trying to identify which one was Orion in there.
Right.
It took a little bit longer than I thought it would. But,
yeah.
But anyway, I found it, and it's a brilliant book, and it goes through the whole conflict of all of this data. But I'm not a fan of overlaying every star number on top of each other like was done here.
It's a little crowded. Yeah.
Yeah. Yes.
Very cool. All right. Well, I don't know if we have any other questions coming through, but if not, thanks again for joining us today. Really enjoyed kind of taking a look sort of back into the past, but using this cool modern tool to do it.
Yeah, thanks for flying. This was the first time I've ever not had to fly open space. and
just sit back, relax.
Yeah, it was,
let
it was
the piloting happen.
Yeah, thank you very much. Smooth sailing and.
Well, very cool. And so we'll share links in the chat to download OpenSpace, and we'll also be sharing. You have a great write-up about this as well that I know was cool to be able to read about that one right there on our screen, which will also be in the chat, and that links to the GitHub. So if you download OpenSpace and want to go and play with these data as well, then it's right at your fingertips. So
yeah.
Well, thanks very much.
All righty.
And thanks everyone for joining us, both here on our Facebook Live and also on the Open Space YouTube channel. We're delighted to have these conversations to share with you, and we've got some more coming up. So stay tuned for next week and beyond. Thanks very much.
Thank you.